Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irham Zahin bin Kamarul Zaman. My metric number is 1200601. So, for today's video, we will talk about eigenvector and eigenvalue and their relation in real-life application. So, first thing first, what is eigenvector and what is eigenvalue? So, for those who don't know, buckle up and let's go.
Now, let's find out first what eigenvector and eigenvalue are. Generally, multiplication of a matrix A changes the direction of the vector x in A. However, certain vectors will still be in the same direction. These are called eigenvectors. Multiplying an eigenvector by A results in a vector x multiplied by a constant which is lambda. The number lambda is said to be an eigenvalue of A if for some non-zero vector x. Eigenvector of A corresponding to eigenvalue lambda. Next, let's know the basic function of eigenvector and eigenvalue. The first one, they help by reducing noise in the data. They also can help with computational extensive tasks through reduction in size. The third one, they help in reducing overfitting. And the last one, they also help by eliminating strongly correlated features.
Okay, now we know what is eigenvector and eigenvalue is. So, let's relate it in real-life application. One of the use in real-life application is in page rank. So, what is the relationship between eigenvector and eigenvalue and their function in it?
Now, let's find out what PageRank is. PageRank is an algorithm used by Google Search to rank web pages in their search engine results. It is named after both the term web page and co-founder Larry Page. According to Google, PageRank works by counting the number and quality of links to a page to determine a rough estimate of how important the website is. The underlying assumption is that more important websites are likely to receive more links from other websites. Now we know what PageRank is. So, what is the relationship between PageRank and eigenvector and eigenvalue? The function of eigenvector and eigenvalue in PageRank is to tell how many votes each web page obtains from other web pages considering their importance. Let's look at an example. Now, we have 4 web pages which are nodes, and as you can see, there are outgoing arrows and ingoing edges. For example, from node 1 has 3 outgoing edges. In our model, each page should transfer evenly its importance to the pages that it links to. Node 1 has 3 outgoing edges, so it will pass on of its importance to each of the other 3 nodes. Node 3 has only 1 outgoing edge, so it will pass on all of its importance to node 1. In general, if a node has k outgoing edges, it will pass on of its importance to each of the nodes that it links to. Let us better visualize the process by assigning weight to each edge. From the results we have done, let's transform into a matrix form. And also, from the matrix we created, let's transpose the matrix. It is easy to see that A is column stochastic, while transpose of A is not. However, the sum of the elements of each row of transpose A is equal to 1. We first show that Z equals to 1 is an eigenvalue for transpose of A with corresponding eigenvector. As x sub 1 is just a real number, hence a scalar, we can take s sub 1 equals to 12, and we have just proved that the vector whose entries are 12, 4, 9, and 6 from top to bottom is an eigenvector of A. In conclusion, the implications of eigenvalue and eigenvector provide many benefits in various methods besides speeding up a process. The development of linear algebra knowledge will be able to increase the use of this skill for the future.
Alrighty, now we have reached to the end of the video. I hope you guys enjoy and learn something from this. And that's all from me. Assalamualaikum warahmatullahi wabarakatuh.